find the, I'm going to abbreviate, radius of convergence and interval of convergence of the series. N equals 0 to infinity, n x plus 2 to the n over 3 to the n plus 1. So where do we start? What do we do? Ratio test. Radius of convergence means I need to do the ratio test. Okay. An plus 1 over an. Okay. So I start by plugging in n plus 1 everywhere. N plus 1. X plus 2 to the n plus 1 over 3, n plus 1 or n plus 2. And then I divide by this an term, so I flip it. And then you look and you group up your like things together. So n plus 1, and n, 3 to the n plus 1, 3 to the n plus 2, x plus 2 to the n plus 1, x plus 2 to the n. And you're going to start simplifying. What could I simplify first? What's something I could simplify?
Dx plus 2.
Dx plus 2. Okay, so let's start there. So I look here, I see x plus 2 here, x plus 2 here. So I'm left with an x plus 2 in the numerator. And then I see 3 to the n plus 1, 3 to the n plus 2. So I'm going to be left with a 3 in the denominator when I simplify those. And then I'm left with n plus 1 over n, which I can't simplify. Or I could simplify more, actually. But I'll do that on the next step. So rewrite our absolute value. And then this n plus 1 over n is positive. The denominator is just a single term, so I can go ahead and divide this to get 1 plus 1 over n. Move your coefficient out in front. Move it out in front. One plus 1 over n. And I need to know that limit now. So the 1 over n, the limit is 0. Plus 1. So it's going to be 1 overall. But you're right, 1 over n would be 0. Erase. Times 1, or you can just leave it. It's just x plus 2 absolute value over 3. So I'm using the ratio test. I need this number, this absolute value, x plus 2 over 3, to be less than 1. Is my absolute value isolated? No? that 3 is there. Multiply by 3. Multiply by 3 to both sides. And then you'll be left with once the absolute value is isolated, you know what your radius of convergence is. So what's my radius of convergence? R equals the number that's right here, 3.
So even if the x isn't by itself, even if it has,
You can have, so it's okay if the x isn't by itself because remember our interval is centered somewhere at A. And so in general, to find your radius of convergence, it's usually x minus A is less than R. So you're trying to get it in that format. My center for my power series is -2 in this case. That's my A value. Okay. All right, my radius of convergence is 3. We want to find our interval of convergence. So first I need to take this guy here and I need to turn it into an interval. The way you do that is you put x plus 2. It has to be between -3 and 3. So what values is x between?
-5
And 1. Yep, I subtract 2 from everything. And I get -5 to 1. So this gives me the interval -5 to 1. But remember, we need to test endpoints of this interval. So I need to go back to my original series and I need to plug in. So originally I had n equals 0 to infinity, n x plus 2 to the n over 3 n plus 1. And let's plug in these numbers here. So let's start with 1. Again, it doesn't matter which one you start with first. We have to plug both of them in, but I'm going to start with 1. And I'm going to plug that in place of x, n, to the 3n, 3 to the n, 3 to the n plus 1. And our last example, we want to simplify things, right?
So the 3n over 3n plus 1, and you get a 3 denominator.
Yes, exactly. So I'm going to be left with a 3 in the denominator, which I'm going to go ahead and pull out. And I want to know, does this series converge or diverge?
It's a geometric series, or is it something?
So it's not quite geometric because for geometric, you gotta have an exponent.
Should not be 1.
Well, you gotta have n in the exponent.
Okay.
So what's something else? Name out some things that we could do. Is this an alternating series? No. Okay, so that's not gonna help. You said geometric, what else?
Could we make it a P-series?
You can make it a p-series, exactly. So this is, for a p-series, we want to have it in the denominator, but we can move it to the denominator and make the exponent negative. So it's a p series. My p is -1. That's less than or equal to 1. So it diverges. You could have also used the divergence test if you wanted, because the limit, so maybe I'll put that here. Could also use the divergence test, because if you take the limit of n, you get infinity. If you get anything other than 0 for the limit, it has to diverge by the divergence test. Okay, so great. I know now that my series diverges when x was 1, so I'm not going to include that in my interval, but I still need to check the other value, which was -5. So I'm going to plug it in. You get n. It's -5 plus 2, so -3 to the n. That's if the exponent is negative. You can move it to the denominator. I mean, you could, if you want. What did we do in the previous one? Look back. They were both 3's, right? 3 to a power. In this one, they're not both 3's. One's -3 and one's +3, but what I could do is I could separate this out as -3 is just -1 times 3. And we can use our rules of exponents to break that up as n -1 to the n times 3 to the n over 3 to the n plus 1. And now they both have a base of 3 going on. So I can use the same trick I did last time. I can simplify this 3 to the n and 3 to the n plus 1 is a 1/3. And I can pull it out in front. And I have -1 to the n times n. What kind of series is that? Alternating. So usually when you have an alternating series, you want to use the alternating series test. So our Bn is n. But if I compute this limit, what's the limit of n going to be? As n goes to infinity, which is not 0, right? I need 0 for the limit in alternating series test, and it's not. So we instead use the divergence test. Remember, an alternating series test only tells me a series converges. To say that this series diverges, I've got to use the alternating series test. But because this limit is infinity, this limit does not exist. Okay. So this series diverges by divergence test. So when I plugged in the other endpoint, I also got diverges, which means I don't include either one of the endpoints in the interval. So it's actually the same answer that we had at the beginning of this whole process, our interval of convergence, -5 to 1, both with parentheses.